Hello everyone. Today we are going to see how the diesel fuel is injected inside the combustion chamber, or in other words, we are going to see and discuss what are the components of the fuel injection system when the type of the engine being used is a compression ignition type. In this figure, you can see the generic composition of the components of a diesel fuel injection system. The engine is there. In the engine, an injection nozzle is mounted. In red color, you will see that the high pressure line is present, which will bring the fuel to the fuel injector from the fuel pump. It is the responsibility of the fuel pump to pick the fuel from the fuel tank. The fuel tank is connected by means of a fuel filter to the fuel pump. This filter it serves to remove any impurities if they are present inside the fuel so that they are not transmitted to the injection nozzle where clogging and congestion might take place. Apart from having a high pressure line, the nozzle it also has a return pipe which serves the function of returning the additional fuel that has been supplied to the injection nozzle. Now let us go a bit further and let us see what are the different components. Once again, we have fuel feed pump and fuel filter. First of all, we will see what is the feed pump. As the name itself suggests, the function of the fuel pump is to pick the fuel up from the fuel tank and supply it to the injection nozzle. In the case of a spark ignition engine, that may not be use a fuel pump. The reason behind this is that the carburetor serves the function of drawing the fuel by creating a pressure drop at the venturi. This drop in pressure by itself serves to bring the fuel from the fuel tank to the carburetor in order to produce the fuel air mixture prior to being injected inside the combustion chamber. However, in case of a CI engine, as we all very well know, there is no use of carburetor. So the function of supplying the fuel remains as it is. In order to rectify this, you need a fuel pump. This fuel pump will pick the fuel up from the fuel tank and supply it to the fuel injector under high pressure. Then this also serves the purpose of prevention of formation of vapor bubbles and cavitation in the pump. Cavitation means when the fuel comes at high pressure, it might erode the inner surfaces of the pump. Okay, this might happen because of the rapidly moving plunger which is there inside the injection pump. We see over here that pressures of about 29 to 98 kilopascals are adequate for preventing vapor formation. There are two different basic types of fuel pump, which are diaphragm type and plunger type, which are illustrated in the figures given in the slide. Then you have the fuel filter. As we have already seen and discussed, that the main function of the fuel filter is to prevent the impurities from being passed through the fuel line to the fuel injector and the combustion chamber. These fuel filters in a type of sort are also present in SI engine. Instead of fuel filter, they are air filters. Okay, if we drive a bike, then in the bikes, the air filters are either present below the seat or they might be present from one of the side panels which is present behind the engine. Okay, so the function is to stop the impurities and particulate matter from being transmitted further. Now the fuel injection pump, the diagram again it shows what are the different components. The very basic component which will supply the fuel is the injection nozzle. The fuel is supplied to this injection nozzle from the injection pump assembly. In the injection pump assembly, you will have a feed pump which will suck the fuel from the fuel tank and supply it to the injection nozzle. You can see that the fuel tank, it is connected to the fuel filter, and from the fuel filter the fuel is supplied to the injection pump assembly, and from the injection pump assembly it is further on supplied to the injection nozzle. Another component that is present over here is the timer, because the injection pump assembly and the feed pump should know when the fuel is to be supplied and when its supply is needed to be stopped. So this timer helps to identify the degrees of crankshaft rotation and thereby drive the fuel pump in required time to supply the fuel to the injection nozzle. Again, you can see that the nozzle has a fuel spill tube, which is the return line, which will supply the excessive fuel back to the fuel tank. Okay. Then we have an inline injection pump system. It looks like this diagrammatically. Okay, all the fuel injectors are arranged in a single line over here. The function of boosting the pressure and maintaining the pressure is carried out by the inline pump. So also the function of fuel distribution is delivered by this inline pump. Injection control, if we look quantity wise, the injection control is controlled by the governor and the timing is regulated by the injection pump, and fuel injection it takes place by the injector. Okay, then fuel injection pump. These are the different positions of a fuel injection pump that we see over here. The basic example is a Bosch type of a fuel pump. The plunger is present. The plunger in the fuel pump, it reciprocates depending upon the movement of the cam. It is actuated by a cam lobe. As the cam rotates, the plunger it will reciprocate inside the barrel of the fuel pump. It will have two ports or two valves. One is the inlet port from where the fuel will be drawn inside the barrel, and the delivery port which is further on connected to the injection nozzle. In the below three figures, you will see that the plunger it has different positions. These different positions are controlled by the control rod. It is basically a type of a rack and pinion arrangement. As you move the control rod, the plunger will rotate. When the plunger rotates, you will see that there is a helical groove along the length of the plunger on its body. This helical groove provides the purpose of, or serves the purpose of, accommodating the required fuel depending upon the movement of the control rod. As the plunger will rotate from figure 1, 2 and towards 3, you will find that the helical groove it is being connected to the inlet port, thereby it will accommodate more quantity of fuel over here. Then you have distributor type of a fuel injection pump system. In distributor type, you will see that the injection nozzles are distributed separately and they are attached with the single fuel injection pump. Rest of the components are as it is: the fuel feed pump, the fuel filter, fuel tank, and the supply lines. The arrangement of the injector nozzles is a little bit different from the inline injection pump system. Again, this is a diagrammatic representation of the system, and the table it shows that the boosting pressure and the maintenance of the pressure is carried out by the rotary pump. The function of distribution of the fuel is done by the distributor, and so also the quantity and timing of injection is controlled by the distributor, whereas the fuel injection in principle is carried out by the fuel injector. Let us go on a bit further now. Then you have high pressure injection system. The main component which differentiates this system is the high pressure pump. It has two different lines indicated in the color red and yellow. The red line it supplies a high pressure fuel, a fuel under high pressure, and the yellow line it supplies fuel under low pressure. Both these lines they are connected to the common rail which is indicated in the figure. This rail it is connected with the injection nozzle. Then again rest of the components will be similar with an addition of a control unit. This control unit will take in the signals from the accelerator pedal, the engine speed from the crankshaft rotation, and the engine speed from the camshaft. This will process the signal and it will give out the commands to the actuators, basically to the fuel pump and the injection nozzle. Then again, what happens in high pressure common rail injection pump, the boosting pressure is developed by high pressure pump. Pressure over here is maintained by the common rail. Distribution, injection controls quantity and timing. It is determined by the electronic control unit. And injection, it takes place by the means of fuel injector. This is an example of a fuel injector. A needle valve is present at the end of which a type of a nozzle, in this case a pintle nozzle, is attached, and a pressure relief spring is also supplied over here. Okay. This type is a hydraulically powered nozzle which lifts under the pressure of the fuel. This is basically a mechanical type of a nozzle and it is considered to be the first generation of the injector nozzles. Then you have the solenoid operated injection nozzle. Instead of a spring, you will find that there is a solenoid actuator. A solenoid actuator, it determines when the nozzle is to inject the fuel. This is basically a second generation injector nozzle. Then you have a piezoelectric, which is a third generation, and you know the function, how a piezoelectric will operate, okay, depending upon the difference of the pressures that is developed. Then we have CRDI, basically, which stands for Common Rail Direct Injection System. The words can be rearranged. It can be also called as direct injection by common rail. Okay, what are the advantages? Noise and vibrations in the engines are reduced because a metered amount of fuel is supplied through a single common rail. To a common rail, to a common head, different injector nozzles are attached and hence noise and vibration might be reduced. Similarly, smoke and particulates and exhaust emissions are reduced. Again, the reason being that metered amount of high pressure fuel is supplied to each individual nozzle as and when required. This further translates into an increase in the fuel economy and also higher power output even when the engine RPMs are low. The major disadvantages, since the arrangement is a little bit complex and more elements are involved and high pressure pump and electronic control unit is involved, the cost is a little bit high. Technology cannot be employed in present engines. Now, this has become a thing of the past. In most of the engines, you will find that CRDI system is being widely used. Then we have a further part wherein combustion chamber of diesel engines are discussed. This over here is an indirect injection system. The indirect injection system, it means that the fuel injector will not be directly mounted over the combustion chamber. It will be mounted a little bit before it. So the fuel will be injected not into the combustion chamber but into a pre-chamber. Okay, the shape of the pre-chamber will determine the swirl of the turbulence that is generated and the vaporization and the homogeneous mixing of the fuel after it is injected inside the combustion chamber. This here it shows different types of arrangements and the shape of the piston depending upon the arrangement of the injection nozzle in case of a direct injection system. Okay, the images they show different arrangements and the different corresponding shapes of the piston. Okay, thank you very much.